It's been a while since I worked on this project. I gotta come up with a better name for it. Floating Navigation Sensor Assembly. Bought this little USB charger thing for the LiPo. It's not great though, it's like 1 amp. And that's like 3000 milliamp hour pack or cell. Anyway, I have both of these in view because I want to talk about how they're both trying to do the same thing, like navigate their environment. This one you attach it to a wheeled base wirelessly and that's how it gets around, but ultimately the goal is to see the environment and move around it. This thing here, it's just dealing with like cones, beams, like single points. It's very crude. Where this one is an actual camera, so you can see things, identify them potentially, although I'm not at that level. I'm just doing basic blob finding stuff. And then the depth probes helps figure out where they are, and both of them have accelerometers, so you can tell, like based on acceleration, how much it's moved, and gyro for rotation. And yeah, combining all those, you should be able to approximate where the thing is. But today, what I'm working on is I'm gonna get this thing connected to ThreeJS. I'll do a basic text-only data transfer just to make sure I got the async I/O stuff down. But the goal will be like have a cube that represents this thing, and I should be able to move it around and rotate it and stuff and see it on the cube. This thing is it has a Pi02 inside it, so processing isn't a big concern, or parallel processing and data transfer, because it's like it's not a janky serial WebSocket like this thing has, where it's limited in the data it can send and how fast. So yeah, that'll be good. I also like this thing just because Python makes it a lot easier to work on it for me versus C++ and single-threaded. Okay, so the mic was not working this whole time. That's great. It has this 4-pin thing, and it's only supposed to be 3. That's what this extender is for, I guess. Weird. Anyway, I added a systemd script to this thing. Oh, it's on already. Yeah, when it's on, the servos are solid. It's using the pig.pio daemon. Turn it off. Movable. I uncenter it. Off center. Hold it. And it self-centers. So you can't see the glow of the lighter. Doesn't seem like it's on. Oh, there it is. Now you can see it. That's just a random tidbit. It's funny, this sensor puts out heat. If you put your hand right above it, you can feel it. It's like a draft and it's warm. So one of the bad things about working on this project is I'm writing the code like pretty much through SSH. You can do it with SFTP too, but I have to at some point mock the hardware, so I don't have to actually write into the Pi, and then I can develop on the desktop, like locally. Just upgrading stuff. Let's see, last time I worked on this, September, yeah. Yeah, and also it's interesting, I can't find the Pi easily on an ARP scan. I have a bunch of them, like 4 connected all the time, and they show up as Raspberry Pi, but this one, it just has a MAC address, so that's weird. But yeah, so I'll get going here once this is updated. So this is a really stupid way to work on this and write code. The IMU has this problem where it has like an IO error, and I was trying to get around that in the past by having this wake script where if you run it enough times, like, it'll get past that error and start working, which is terrible. But and anyway, if you run the command on its own, like, it works. Things started, and let's see, Python 3. It's like try value. It's like, yeah, it's not reliable. So what's the non-single one? 2. Yeah, there. So the 6050 couldn't even run this long. Like, it would just die. But the 9250, which I stuck in there even though it was bigger, I had to cut some parts out, is more reliable. Like, the values stay up. The issue is, after I tried to, like, abstract it using classes and whatnot, I trying to suppress those warnings. This is the local copy. The actual copy is here. This is SSH'd into the Pi. I don't know if you should set the MPU values before you try to wake it. The wake doesn't do any settings. Got a sample, subprocess, wake. Trying to call the wake in here in the setup. This is a boolean, like it's awake. I think it would make sense to set this up and then try to wake it, which is what I had initially. But the errors are not being suppressed. I think that's what I was trying to do with try. Wait. Oh, actually, yeah, when I call this, nothing happens. I gotta put start. Where did I go? Methods. Yeah, I think I'm supposed to just import this somewhere. imported path. Crap. Okay, I'm gonna undo that. This is some really nasty stuff. I am not a Pythonista. I'm a noob. So it works in here because of the imported path up here. What does this one do? Sets it, configure, and it just samples it. I need to read. When I try to sample it, it fails. Are these the same? Yes. PU configure print and PU read set parameter list. Crap. Need that back. Yeah, there's like delay when you work out of SSH, so that's not good. Anyway, that's what I'm working on right now. I've got the socket bridge. It's off here, but it'll dump it here. Then I just have to chew the numbers with JS and plug them into ThreeJS. That part I've done before, but I'm just still trying to bridge and then turn this into a thread I can start when the robot starts. And then the telemetry will start straight to the web interface. Let's see, how is it? Yeah, it's not too bad. Still have some RAM and CPU is barely used. The lazy thing I can do is, in the previous video I just ran this and it worked. I can also just turn this into a thread where it's a function that continuously dumps out these values for anything that calls it. And you can use that for the streaming. The other thing I'm still not sure about is I need those values locally as well in order to keep a local telemetry on the robot to remember where it is. I don't know if I need a DB for that or just memory. I think ideally you would just chew through the values and add to the state. That could just be like an object dictionary. You store like based on time where it's been. So there's a problem working through. I ended up just making a thread wrapper around the raw MPU dump. So that function continuous IMU sample is turned into a thread so it can run independent of the parent that calls this method. The issue is the set value, which I thought it would work, but I guess not. So I import this method IMU setup in sensors. This is where the IMU is initialized and stored. I pass this variable here, so this is the value I want to update every time the IMU goes through and does its thing. However, it is not working, so I get it right here. The variable pointer or location, I don't know. I assign it to this local one here, and then I set the value of it. That might not work like that, you know. Yeah, I don't think it works that way, because it's probably just updating the local and not the imported variable. If you do return here, it ends the loop. So, I don't know. But the IMU sampling is working well, at least. I don't have any like catches when it stops, but this is at 100 millisecond sample rate. Okay, I got it, thankfully. So that'll be easier to explain with here. So this is the WebSocket connection. That's what's running here. I run it. Initializes sensor instance. God, yes. And when it does that, the IMU calls this sampling thread, which starts over here. What's that? Oh yeah, it has to. I need a reconnect function on there. Anyway, it starts it here. The reference to the IMU, this guy, is passed down here. This is wrong. I had to update it in code. It's just self. When I call this method here, I'm actually passing none. Anyway, so now that you've got that IMU, then you go here, you put IMU dot access the thing, set it, and then it's working correctly. And then this just accesses the nested class IMU. It's lowercase I because the instance is set up here. So yeah, you set the value to the sample, or actually you're accessing the sample here, and then you send it with the. So yeah, that's working. Now I gotta perform math on it and plot it. Just want to check something real quick. Yeah, there's something weird too. Like it's already a JSON, but I had to JSON it again. And let me make sure that's not just because of the none that I was passing in originally. Oh yeah, it won't start until you connect. Okay, that's good. Array of arrays. Alright, so we got our values. This pulls everything. I mean, look at that. Damn. The freaking teensy serial WebSocket can't do this. Not with my code anyway. It's like this is I set this rate at 100 milliseconds. It can go faster than this. Alright, I gotta think about how to. What's gonna happen is I'll have a ThreeJS plot here, rotatable, and you'll have a dot, which you can plot vectors in 3D and add lines between them. So that's how you can track the trajectory in 3D space. And when you put a cube to represent the dot, you can rotate it, you know, whatever angle to match the orientation of the IMU in real life. And then eventually you can import the SketchUp model of the assembly and target the individual parts and actually rotate them, reflect that as like a 3D, I don't want to say simulator, but it shows the 3D thing. That's not going to be part of this task, but that is possible because the ThreeJS, when you export the GLTF file, you can target the components, I believe, because it's JavaScript. So I just stole this code from the Torque LiDAR project. It's just a basic grid, and then from here on you can just start plotting stuff. I have to think about the math, how to pull like velocity and position from acceleration samples. At least the data I have and the connection is like uninterrupted, reliable, so I don't have to deal with like averaging for missing data. So I've tried my first attempt at making some displacement function, and the problem is even when it's sitting still, it's supposedly moving. The acceleration values are never just 0, so it's x and y. So I'll have to reduce that. I see 0, 0. Let me see. This is going kind of fast. I got it at 50 milliseconds. Yeah, so I guess I could try and dump. I'm moving it. Try and dump 0, 0 values. Ignore, I mean. Let me see what that looks like. So this is wild. I've got this sampling at I think 5 milliseconds. And, like, you can hear it. So I've got H-top, and you can hear it process this. I'm not sampling right now, but I can. Let me check if you can hear this. Okay, so it does seem like you can hear it. So let me turn this sampler on. Dude, look at the speed of that. I'm still working out the filtering. It's not reversing the value, so it's not subtracting displacement. Yeah, that's crazy though. So I think I have to make a calibration thing where it's sitting still, it'll record values, and that'll be like the threshold overcome. The problem is, and the other thing, the direction of the acceleration doesn't make sense to me when you see a visual reference of the IMU. Y is, well, this is a top view. So blue is the z-axis, green is y, that's forward. So acceleration, that's positive y, but when you move the robot that way, so to the left up there I have like a negative positive thing. If you watch the robot, like this way is supposed to be positive, but it comes up as negative. See, negative. Go this way, it's positive. And this is the threshold, like it's not enough. I'm experimenting right now. I've got 0.05 meters per second square, which I don't know what that means. Like the values, when you look at them, they're around that. Oh no, I do see double zeros when it's sitting still. Zero zero 8. 0 0, okay, double zeros. I could try that. So you'd want this to be 1. Yeah, I don't know. Let's see. Positive. Yeah, this is not reliable at all. Sampling at I think it's 1 hertz too. Or is it 5? I don't know. I set the values to sync here. 1 hertz, yeah. Which, that's probably overkill, but I don't know. I'm not sure like what time frame this is.